Okay, can you see my presentation now?
Yeah, I can see your presentation. The forum is yours. You can start. Thank you.
Okay, thank you very much. Good morning in India, good night from Mexico. So the work that I will present in now is called Multimodal Data Evaluation for Classification Problems. And this work was done with my colleagues Daniela Moctezuma and Jorge Garcia from Mexico. Okay, so one of the perhaps the main motivation for this work is to use and to take advantage of all the information and all the data and information that is sharing by the people on the internet, and mainly in social media platforms such as Twitter or Instagram or Facebook, etc. And we think that it is very important in order to know what the people is feeling and what the people is thinking about many topics and about many things that is happening around them. So we can find many insights of all these things because the people shares things that is humorous, sarcastic, motivational content, offensive, etc., about people, about some events, about some products, and we think that it is very important to know something about the people that is sharing all these things. And in the last years, the social media information is one of the main inputs for many of the machine learning algorithms that is developing right now. So it is the main motivation for our work. And as I said before, it is very important to know some characteristics of the people that is sharing this content. For example, if the people is in some place, if the people that is sharing this content is man or woman, if the age of the people, etc. So, but it is very challenging for many reasons. Maybe the main reason is that this kind of data is unstructured, which means that it's not in a vector form, which is it is necessary for all of the machine learning algorithms. And generally, it is multimodal, which means that it is composed of different types of data. For example, text, images, video or audio, which is shared in the social media platforms such as Twitter. So it is challenging, but we think that it is very important to propose some models for try to get some insights of all these aspects. Okay, so there are many works in the last years that deals with multimodal information, and it is known, at least from in some kind of information and in some task, that multimodal data could improve many supervised and unsupervised machine learning tasks, such as sentiment analysis on Twitter data, for example. Maybe it is something difficult to know that if we read the text of this tweet, that it is a comic or some hilarious tweet from this person, but if we can see the picture or the video which is posted with the text, so we think that it is more easy to know what the people is sharing, and what is the purpose of this post. But it is difficult to deal with this kind of data. There are we think that there are two main difficulties on this data. The first is that we need to obtain a vector representation for each modality of the data, which means that we need to transform the information of the text into some vector information, which means that we need some numbers in such a way that the machine learning algorithms can work with it. And it's the same for the images or for the video or the audio, which is posted together with the text in this tweet, for example. And once that we obtain the single or the representation for each modality of the data, we need to know how to combine them in order to have a complete representation of all the modalities of the data. Okay, so but maybe first that or before that, we think that how to deal with the representations of the modalities of the data. Maybe the first thing is to ask us if it is true that using different modalities of the data is always better for some machine learning task, supervised or non-supervised. And if it is not better, if not, on which scenarios happens that? And what are the requirements of the data or the models in order to have some advantage by using all the modalities of the data? So in this paper, we try to investigate about all these questions by analyzing through the usage of two modalities of data, images and text. So we analyze in separate ways and combining them in order to address two classification problems, which is the MEMS classification that I will explain soon, and user profiling. That these tasks are very known in the research community for natural language processing and image processing, and these are the two tasks that we address for this work. Okay, so the task that we will be using is the first one is the motion analysis, which is proposed by the International Workshop on Semantic Evaluation, or CEMEVAL, in the last year. And this task consists on trying to classify the memes that the people shares on the internet in different categories. This is a very difficult task because we can see that maybe the same image is used for many purposes on the memes. And before this academic competition was proposed on the last year, there was not so much research efforts to try to work with this kind of data. But it is very important because, as was said by the organizer of this workshop, that the digital constructs of the memes are so deeply ingrained in our internet culture that in order to understand the opinion of a community, we need to understand the type of memes it shares. So it is the first step that we that we address, and the data set consists on 8,000 of images, which has the image and the text of the meme. And from this corpus of data, we use 7,000 for training and 1,000 for test. There are two tasks associated with this academic competition. One is the sentiment classification, which has three categories: positive, negative, or neutral, and the humor classification, which has these categories: sarcastic, humorous, offensive, or motivator. And the second one is more challenging because one meme can have more than one category. So we will see in the result that actually it was very difficult to solve. And in this case, we have only English language for all the data, or for all the text of the data. And the second task was author profiling, which is a very known academic competition in the natural language processing research groups. And the author profiling consists on trying to classify or to obtain the gender of the user, which is sharing the contents on Twitter. And the corpus consists of a dataset of 3,000 Twitter users, and they provide 100 tweets and 10 images by users or per users. So we can see that we have an unbalanced dataset in this case, and also we have English and Spanish languages for this task. Okay, so the model that we used was a combination of some representations for this modality of the data. Maybe the first important thing of the model that we proposed was that we tried to model all of the data in a text form, which means that all the image was translated, or was translated on text by using image captioning method. So here, well, I will explain in detail this model. And once we obtain the text description of all the images, we make a fusion step by concatenating the caption of the image and the text that was provided with the data, and then we obtain a vector representation of the text by using some method that is very similar to the back of words scheme, which is very known in the natural language processing field. And finally, we use a classification model which was based on a supervector machine algorithm. Okay, so the first step is to translate the content of the image into text. So we use a very known encoder-decoder deep learning architecture, which consists on the encoder is based on a convolutional neural network with a pre-trained weights based on the Inception version V3, which is very known in the image processing community. So in the encoder step, we use this convolutional neural network, and we have at the end, we have, after all the convolutions and the pooling operations of this neural network, we have a vector representation of the image. Then in the decoder step, we generate the description of the image by using a recurrent neural network based on gated recurrent units. And also we use a layer attention or an attention layer, which the objective of using this attention layer was to try to know which parts of the image are important in order to have a correct description of the image. So this is the architecture that we used for the image captioning step. And so we have, this is an example of the dataset that we used for training this neural network, which is based on the Flickr corpus, and it consists on, well, a lot of captions related to more than 31,000 images. And this is an example. For every image, we have 5 descriptions of the image given by some users. So this was used to train our neural network. And for the Spanish language, we used automatic machine translation algorithm. So we have 2 versions of this dataset, one in English and one in Spanish. So we are able to obtain descriptions of the images in English and Spanish. Okay. Then once we obtain the image caption or the description of the image, so we concatenate with the text of the data, for instance, the text of the tweet that all users post, or the text of the meme. And then we use an algorithm to obtain a vector representation, which is based on an algorithm which is called micro-TC, and it consists on construct a matrix which is very similar to the bag of words, which consists in the frequency of the words in the text, but we made some preprocessing operations on the text, which it can be, for example, make a lower casing of the data, or to remove the hashtags or the number of the text, etc. So by means of an optimization algorithm, we find an optimal representation of the text. Then we apply some tokenization on the text, which allow us to separate the text in words or n-grams in general. And then we obtain a vector representation of each of the texts of our dataset. And finally, we use a classifier based on a supervector machine with a linear kernel. Okay, so so this is the method that we use, and the result that we obtain in the case of the image captioning step. And these are some results for English and for the Spanish language. And in general, there was we obtained very, very good results for Spanish and English, according to some metric, which is called BLUE, or bilingual evaluation under. So the metric which is very used in automatic machine translations. So this is the input for the classification algorithm. Well, this is the input for the vector representation of the text, and then we concatenate this representation of this textual representation of the image with the text that is provided by the datasets, and then we use our supervector machine algorithm. So for the meme classification, in the first task, which consists on the polarity classification, which is a positive, negative, or neutral of the meme, this is our results for the test data set. We obtain good result if we compare with the best score competition of or academic competition for this data. And for the second task, which consists on this task on the humor classification, which I said before that is very difficult because one meme can have more than one category. So we obtain these results here in the macro F1 metric. So the results are not so good when we use text and the caption of the image. We can see that actually the result is worse than using just text. It is the same case for the first task of the polarity classification. So in this case, it's not very useful to use the image and the text information of the data. And for the user profiling, which consists on classify with the gender of the user of the tweets. So in the case of Spanish language, well, we have these results, and just for reference, these are the best results of the academic competition. So in this case, we are doing better in the Spanish language, but not so good in the English language. And we can see that in this case, if we add the information of the image by means of the caption of all the images of the datasets, improves actually the results for these tags, at least for the Spanish language, and maybe it's not so good for the in the case of English language, but anyway, it is better when we use text and image information. Okay, so summary conclusions of this work. Well, we use a multimodal methodology for image and text data, and we address two difficult classification problems which was proposed in some academic competitions. One of them was user profiling and memes polarity classification. And we make a comparison of the results by using just the text or by adding the information of the image. So in general, our methodology that we proposed for this classification task had good results in both tasks, but some better results were achieved using only text than using image, which means that not always is better to add information from the image, at least by translating the image on text. But we have some characteristic or some issues in the data. The first is that we have unbalanced data types, because we have only 10% of the data as images. So we have more text than images, and this is problematic for this task particularly. And this is a big problem that we have the same image for different categories. This is for the memes polarity task. And we have an unbalanced categories and topics on the data, which means that we have more, maybe we have more sarcastic tweets of the data or of the memes, I'm sorry. We have more sarcastic content of the memes than humorous or other category. And we think that better knowledge of the contribution of semantic textual description of images can be obtained with balanced data types. And as work in progress, we are adding some other representations for both images and text. In the case of image, we are using the representations that we obtain with the convolution neural network. And for the text, we're using another embedding representation obtained with some methodologies based on the transformers, such as BERT, and other embeddings algorithms, such as Word2Vec or fastText. Okay, so this is all. Thank you very much for your attention. And if you have any questions, I will be happy to